Good.
Yeah. So have you officially retired now after leaving Scaled?
Yeah, I
or-
think I probably am retired. I didn't, last year, I didn't earn a penny
Ah.
in consulting work, so I guess I'm through. That's fine.
Yeah. Okay.
It's all right.
Yeah.
Although I was up at Scale and chatted with those guys, and they're,
Yeah.
I've got some stuff I'm going to feed them about
Yeah.
simulator stuff that they
Oh, okay.
probably can use.
Yeah. How long were you at Scaled?
I never worked at Scale. I just was a consultant.
Oh, I see. Okay. Okay.
Um, when I retired in '87
Mm.
from the Air Force,
Mm.
I Bert was just getting ready to fly that tandem wing transport,
Okay.
and I had been working on the X-29 and the X-31 and some other DARPA stuff. So I knew several guys at DARPA,
Okay.
and they said, "Why don't you become a consultant and be our on-site rep at Scale
Mm.
for the ATQ program?" I thought, all right, I'll do that.
Okay.
So I just, I spent almost full time up there watching what they're doing and helping where I could and stuff
Yeah.
like that for that whole program. And I've known Bert since he worked out there
Ah.
a long time ago. And so he called me and asked me to. Well, I've been kind of keeping track of the SpaceshipOne program for the last 5 years or so. He and I have been talking occasionally, and he finally, when they started flying it, he asked me to come up and just be a consultant on
Okay.
the testing. So I was in the control room on all the flights.
Okay.
And had-
Yeah. Yeah. I
had a great
heard your
time.
name up there and saw your picture in the control
Yeah.
room, so I just assumed you were a regular employee up there. So. Okay.
No, I just was consulting for a short block of time there.
Yeah. Well, that was certainly an exciting program to be
Oh,
a part
yeah,
of.
yeah.
Direct connection back to the X-15 after finally beating the altitude record there after all
Yeah,
those years.
right.
Yeah, yeah. Well, I guess just to get some background, tell me about what led you to Edwards.
Well, let's see. I graduated from U of W in '55, and I had been in the ROTC program, so I was expecting to be called active duty momentarily. So I didn't know when, but comes job interview time, and I interviewed several places, and one of them was the Edwards flight test group, and I thought, well, if I could get down there, they said they could pull my card and assure that I could stay there rather than go
Yeah.
off somewhere else.
Okay.
So that's what I did. I came down, I worked about 3 months as a civilian, and then I was called active duty and stationed at Edwards for 2 years.
Okay.
And that was fun, so I stayed.
Okay. Yeah.
That was an exciting time. That was between 55 and about 59, 58. And all the Century Series fighters were showing up.
Mhm.
And they were short of people and short of pilots and everything for all these different airplanes that were coming on board and trying to do flight testing. So it was a lot of fun, a lot of responsibility early on.
Yeah. What was the job you were doing then?
Well, I spent the first year working on the couple of the YF-105 and the YNF XF-104 and a couple other 101, just flunky type stuff. And then in '56, I was assigned as the F-100C stability control engineer. So I did that program with Mel Apt as my pilot. And at that time, we did a test program with 4 guys.
Yeah.
We had a crew chief, we had a pilot, we had an instrumentation guy, and a flight test engineer. And that was all there was, We put all the stuff together and wrote a report and did the whole thing. And then after that, I did the F-104A stability control test as a project engineer, and Ivan Kinchlow was my pilot on that one. So that's how I kind of got into the X-15.
Yeah. Yeah. He was original project.
He was the
pilot.
original project pilot.
Yeah. Yeah. Actually.
And of course, that whole time period, I assume you've gone through all this
Oh yeah.
routine, but in that time period, Kinchlow made a flight in the X-2, and the X-2 was going to be like the X-1. It was going to be Air Force set records and then turn it over to NASA, and NASA run the airplane, run the program. And when Bell was killed in the airplane, and that was the last airplane, there was a big furor. You can't do that anymore. NASA doesn't get their airplanes, and you know, it wasn't managed well and all that. So that's when they decided to do the joint program, because the Air Force felt like, number one, they were well, one of the biggest gripes the Air Force had was NASA took 3 years to publish a stupid report. And here's all these research airplanes and all this neat stuff going on, and the Air Force didn't have any direct insight, couldn't feed it to contractors because it was in editorial review, NASA. So that was a bug in their side, and they wanted to fix that by having direct participation in the program. And of course, NASA wanted to have the Air Force not running that envelope expansion thing like they had been doing. So they decided to do the joint thing, and it worked really well.
Okay. So was it working with Kinchlow and stuff? I mean, as you say, that led you to the X-15?
Well, yeah. I'm not sure how on the original assignment. I was working for Jack Waseski, who when I first started, he was the chief of fighters, engineer. Then he worked into flight research, and I moved with him, and the two of us, kind of got involved in the X-15, and Kinchlow, of course I knew Kinchlow well, so that got me in there at the very beginning when they decided to go joint, and they wanted somebody on the program from the Air Force, as well as the engineer, or the pilot. They wanted an engineer and a pilot. And so I was the engineer, initial test engineer that went down there, full-time assigned to monitor the program and feed stuff back to the Air Force.
Well, actually, I'd love for you to talk a little bit about Kinchlow. Of course, obviously he was the original project pilot, and was killed not too long before that, so not a lot is known about him from the standpoint of where it was going on the X-15. I talked to Walt Williams about him and stuff. I know they were pretty good friends too.
Yeah, well, he was really well liked.
Yeah.
Really gregarious guy, and everybody liked Kinchlow. But he wanted to fly that X-2 so bad. I remember that probably Walt Williams had told you this story. Walt and other people, including Everest, told him, you're too big for it, you won't fit. So Kinchlow said he was down there one night with Pete, I guess. They went down there. He was going to show him that he could fit. And by golly, he squeezed himself in there and said, see?
Okay.
And then they got Walt down there, and everybody agreed, well, okay, maybe you can. Because he was a big guy, you know, big husky, 6 foot something.
Yeah, that was a tiny aircraft.
Yeah, it was a little dinky airplane.
Yeah. That's amazing. You see pictures of the guys standing next to it. I mean, it's like it's below their knee just about.
Yeah. Well, he got, I don't remember how many flights. The last one was the altitude record, and I shouldn't say we, it wasn't me, but Dick Day had established a simulation of the X-2, really crude. He had a little B-17 bombardier stick and a round oscilloscope with a couple of lines on it that represented the horizon he was flying. But it was a good mathematical representation of the airplane. And it had all of the good and bad characteristics in there if you knew how to see it, how to look for it. Wasn't really like flying an airplane, but if you knew what to look for and what to ignore, you could see what was going on. And
I know the Air Force got a lot of criticism for putting Mel Apt in there and telling him to go out and fly Mach 3. I mean, what's your take on that whole situation?
Well, let me go back where I was. That Kinchlow got in the airplane, and he went down and spent some time on the simulator with Dick Day. And Dick kind of coached him through all the stuff and said, here's what happens if you do this, here's what happens if you don't do this, and how to fly it. And as a result of that, him seeing the simulator and understanding what he saw, when he did his altitude flight, he got cocked up and the engine burned out, and when it burned out, the airplane was in a 45-degree left bank. And he knew that he should not try to correct that, because they didn't have any reaction controls in the airplane. So he floated over the top in a 45-degree bank and didn't correct it until he got back down into the atmosphere and the angle of attack was low and pulled out. And that was as a result of his awareness of the simulation. He believed it and followed the trends that were showing, and he kept out of trouble. Now Mel was assigned and didn't have as much time. I don't remember all of the timing, but he didn't have as much lead time. He did fly the simulator, but not very much. And whether he didn't believe it or who knows. But he knew that that was the wrong thing to do, was to do a turn at high Mach number. He should have known that.
Yeah, that was what got him.
Because it was in the simulation. You could see that tumble in there.
Yeah.
So there are a couple things. Number one, nobody figured that he'd fly a perfect trajectory on his very first flight. And he got, about another 8 or 9 seconds of burn time out of the engine, and we got faster than anybody thought he would be. And then he, for whatever reason, tried to make a turn.
I heard one time that, again, it's just, now the X2, to get out of the X2, you popped the nose out and jumped out, is that correct?
Yeah, you had to fire the capsule, and then you had to step out of the capsule with a personal chute.
Okay, yeah. So, and I'd heard somebody said that because of the drag and everything, after the nose was knocked off and stuff like that, that the thing actually sort of windmilled down almost like a helicopter.
Yeah, it came down in flat spin. Hardly heard it landing. Yeah. Well, what everybody speculates is that the airplane, it did this yaw side slip thing and then tumbled. And there's about 13 Gs, and they got all the records. The records were recovered from the flight, and that probably put Mel out of consciousness. And it was plus and minus 13, so he probably was having trouble seeing. He regained consciousness, and he recognized he was in a spin. He put in spin recovery controls for an upright spin, and he was in an inverted spin. And he probably didn't have the vision to tell that he was in an inverted spin. And so when he finally, that wasn't working, so then he fired the capsule. There's another 13 Gs or 10 or whatever. And he was out again, and by the time he came to the second time, he was too close to the ground, didn't have time to step out.
So it's the brake point is just behind the cockpit. That whole section goes
front
out,
end came
and
off.
then he backs out of it basically. Is that right?
I don't remember if he backed out or. Seems like he had to open the canopy and kind of from the side. I don't remember exactly how he got out. It wasn't difficult. It was just that you had to do that.
It's not like the capsule. Seat, you pull the handles and everything else is done for you.
It wasn't automatic. He had to make that extra step. He was apparently in the process when he hit the ground.
Well, back to Kinchlow on some of this now. Let's see, I don't recall exactly, how close we were to the first X-15 flight when he had the accident? The 104?
50...
Sometime 57 or 58?
Yeah, it was 57, I think. It was late 57 or early 58, and when was the first glide flight?
Well, first glide flight wasn't until 59,
June of 59.
It was about a year before the rollout of about things. That was October of 58. I'm not sure. Okay, you got to look at
when he was killed, that kind of got to me, and I accepted a job at Boeing. Went up to Boeing, worked there for 6 months. And the reasoning was, well, I'm from the Northwest, and I kind of wanted to go back up to the Northwest, and plus the fact I was running out of hands and fingers toes of the pilots that I knew well that had been killed. In that time period, from 55 to 57, there were a bunch of guys that were killed in airplanes, and I was in the fighter section, so I knew all these guys. And of course, Kinchlow I knew real well, and Mel, and I kind of thought, I don't think I want to do that anymore. So I went up to Seattle for about 6 months, and I couldn't find a place at Boeing that was anywhere near the challenge that was down here. So my boss called and asked me if I wanted to come back because they had to fill my position, and I said yes, so I came back down.
Okay. Was that about the time you went directly into the X-15 program?
Yeah, I went right back into the X-15 full time again. And but it was the glide. I was up there the summer of '59, so the first glide flight occurred while I was up there.
Okay. Yeah. Was it your time at Boeing that later led you to be part of the X-20 program, since they were the prime contractor?
That was what I was assigned to when I went up there, was in the X-20 office.
Okay, so you went from the 20 back to the 15, then went back to the 20 later on?
Yeah, right.
Okay. So when you got onto the X-15, what was your position? What did you do on the X-15?
Well, we decided that probably the best way for us to integrate into the program as a joint program was to get involved in the mission planning. Because especially during the envelope expansion, because during that time period you got to go touch base with all of the technologies that are involved, all the systems, the heating, stability, everything. All these experts have got something to contribute, and as a mission planner you have to take that all into account and plan the flights. And of course we were heavily dependent on a simulator. So that was what I did, and I got to know Dick Day real well. Dick and I were buddies, and the two of us were the mission planners for the whole envelope expansion phase.
Okay.
Dick was the NASA guy, and I was the Air Force guy, and of course the NASA pilot was Joe Walker, and the Air Force pilot was Bob White. So the four of us worked very, very closely together in that first year and a half when we were expanding the envelope. And that worked out to be a really good plan to get into the mission planning aspect of the program. You could touch base with everybody, you got to know everybody, and when there was technology coming out, you were right there, and you could write a little memo and send it to somebody, and it was worthwhile. And I was, accepted by the NASA people as one of the team members. There wasn't any of this stuff like you read in Yeager's book about Air Force versus NASA. It wasn't like that at all. And Bob White, I know, feels quite strongly about that too, that it was a much closer knit team that worked together to get that job done.
I've heard that from a lot of people that, from both sides, Air Force and NASA side. It's like, we were all working on the same program, we're all part of the same family.
Yeah, really was.
Yeah. So one of the things that I did hear, though, was there was some separation between Air Force and NASA versus like North American, because North American was a union shop, and there were some things going on there. It's like I talked to John McTeague, who was responsible for rebuilding Aircraft 3. After the explosion and stuff. And he said they took the aircraft back down to North American, and North Americans there, you can't work on that airplane here unless you get all your union guys. And it's like, okay, well, we'll just take it back then, or whatever. It's a little bit of friction on that.
At that time, NASA Dryden had a really good capability in-house. They could build things and do things in-house. And the lifting bodies, of course, that came out of a non-union shop, where they could send their instrumentation guys in and put the instrumentation in as it was going together.
Yeah, that whole thing with the lifting bodies was an amazing program. That just, people like Paul Bickle and stuff, they were just sort of doing it on the, nobody knew what was going on.
Janitor fund.
Yeah, John McTeague did a lot of that. He actually left and went to Northrop for a while working directly on that. So, So as a mission planner, you were an overall program planner, not a specific aircraft.
No, we were planning specific flights in great detail.
But I mean, you were not on Aircraft 1 and Aircraft 1.
That's right. It was for all three airplanes,
Right.
And we we were putting together the sequence. Dick and I would sit down and talk and plan and look at the sequence of flights, maybe 5 flights out, not more than that, and try to see, okay, if we do this one this way, then we'll learn enough to go do this one. And we did it so that we build up in speed at relatively low altitude, got some stability data, and that would allow us to go up in altitude on the next flight and use that same angle of attack Mach area where we had just explored in a speed flight for the entry. So you were flying an entry in the same range that you had just gotten data. Whereas if you try to do the altitude first, you committed to an entry and you don't know what's going to happen. Whereas the stability on a speed flight, you could back away if you didn't like what you saw. So that was the sequence that we went through. We'd go out to a higher Mach number, about a Mach number at a time, and then we'd go a little higher in altitude, and then we'd go to another Mach number and another higher altitude. And we did that with the small engines. Got to 130,000 or so in Mach 3, and then we waited around for the big engines. And that was a blessing because there were a lot of systems that weren't working well, and we got a lot of the bugs out on that small engine program, just cruising around at Mach 2 and 3.
That worked out really well then.
Yeah, it was beneficial, even though everybody thought, man, we got to get that big engine and get going, but it was beneficial.
Maybe look at what happened when they were doing like the test stand run and they had the explosion.
Yeah.
And it's like that had happened during a flight. I don't.
Oh yeah.
The consequences might have been a little different than what happened. I'm still amazed that aircraft was able to be rebuilt after that.
Yeah.
Again, it was one of the things I'd never really realized before. But of course, everything from the wings back was pretty much new.
So yeah.
But I just always assumed that we rebuilt the aircraft, we're going to put new wiring in and all that. They were telling me that they actually, at that point, everything from there back, all the wires were spliced at that point, and that actually gave them a few little difficulties later on. But the aircraft through is very unique because of that.
Yeah, could be.
Yeah.
I didn't get involved in the detail. I know that they had the same thing when the thing broke out at Rosamond.
Oh yeah.
Production break, it looked terrible. Fairly easy to bolt it back together again.
Yeah.
With some reinforcement.
Yeah.
Plates in there.
Actually, kind of think of it because that was aircraft. Was that aircraft 1 or 2?
I think it was 2.
Okay, it was 2. Yeah. So aircraft 3 had the big one. Then we broke in half on 2, and then number 2, of course, had the rollover then. So aircraft 1 never had any of the big strucral failure problems like that. Yeah. So it's pretty much intact still sitting in the Smithsonian. Yeah.
Well, that was part of the whole mission planning thing. We during the envelope expansion, we were kind of running the show because of the flight sequence. But we'd say, okay, this next flight's going to Mach 4 and this altitude, and then we'd go around to the heating guys and the stability guys and the performance guys and say, what do you want to do on this flight? And so they'd give us test maneuvers or particular data or something, and so that was part of the integration that we did, is try to see what everybody needed to have done in the way of research data, get it while we're doing the envelope expansion. And then once we got to the max altitude, max speed, then it kind of turned into a research program, and we would go to them to see what kind of a flight do you want. Plan the flight around what the research guys wanted to do. So we had heating flights and speed flights and different maneuvers that we would do specifically for their research.
Okay. Yeah, they got a lot more into the experiments and things that were added on. Watching a missile go off from Vandenberg, or testing heat tiles for Saturn V, or
camera.
Yeah.
Got the camera in there.
Oh yeah. I always heard they never actually were able to get it. It was like either the launch or the X-15, one of the two never got up at the same time.
They did get up there.
Did they actually get any footage of that?
No. Well, I'm trying to think of what happened. Oh, you have to talk to Bill Dana. He was the pilot.
Mm-hmm.
And as I remember, they got the airplane up and they got the missile fired and the door didn't open or something.
Mm. Yeah, it sounds.
And Bill watched the thing go by, but didn't get
Yeah.
any pictures, something like that.
Yeah, yeah. Yeah.
But it was a real hassle trying to get those two things, the two countdowns.
Uh-huh.
Oh boy.
Oh yeah, especially back in those days. It have
Yeah,
enough trouble
yeah.
today, but back in those days, yeah, launching a rocket took a lot longer.
Yeah, that's right.
Yeah. And then later they had the micrometeorite experiment. They had the pod, the wingtip pod and such. And Bill did a lot of those flights too.
Yeah, later on there were 15 or 20 experiments on each flight. There were all kinds of things hanging out and different things that were not passive experiments,
Yeah. Yeah, they were the basically the second half of the program pretty much were from about 66 on, something like that. Was just pretty much for experimentation. It really didn't have anything to do with the aircraft anymore.
That's right.
Yeah.
And we had flight plans, stacked up over here, and if you guy wanted to go to 240,000 feet, well, we had a 240,000 foot flight plan all made up, whatever the mission was.
Yeah.
We did fly some, right after we got the envelope expanded, we flew some heating flights, specifically for heating. I think we only flew a couple, because Bickle, that was a challenge and a half. Because what these guys wanted is they said, we want you to go out to Mach 5, and we want you to hold a constant angle of attack, and a constant Mach number, and a constant airspeed for 10 seconds or something like that. Well, shoot, the only way you can do that is you get out to a Mach 5, roll into a big turn and pull about 5 Gs.
Mm-hmm.
And if you do it right, you can hold everything just constant, keep from climbing, you can hold everything constant. But the problem is that when you do that, you're no longer operating in the vertical plane like we were used to doing. You go up and you come down and you land. Here now you got to aim over here.
Yeah.
And if the engine burns a little shorter or a little longer than you expect, you're not headed where you think you are. And yet it had a lot of lakes out there, emergency lakes. It got to be a real planning nightmare trying to figure out how to get one of those flights off safely.
Yeah.
We did a couple of them, pulled it off and got some data, but Bickle said, we're not going to do that anymore.
Yeah, I talked to Mel Thompson on that. He was one of the people that did some of the
he was one that did some of the heating flights.
Yeah, he was talking about those angles and such. Now, so as a mission planner, you were, as I say, overarching everything, versus like the flight planners were usually specific aircraft. Did you know like Jack Kolf? Did you know?
We're all doing the same
all
thing.
Doing the same thing? Oh,
yeah,
okay.
but see, Jack came later.
Okay.
Armstrong came later.
Right.
The early flights, the envelope expansion was Dick and I.
Okay.
And then these guys came in, Warren Wilson and Berwin Cook, some of the other guys that came in and did the same job, planning individual flights on individual airplanes.
Okay. Okay. Yeah. So you had the second generation coming.
Yeah, that's right.
Okay.
So 9 years, that's a long time.
Yeah. Yeah. Overall, did you think the program? Of course, everybody's sitting there. Why didn't you get Flight 200 off? And all the problems finally snowed out there, all the other stuff. But do you think the program was ended at the time it should have ended? Or do you think there was more life left in it?
At the time, I didn't think so, but I think looking back on it, it was probably a wise decision to stop it, to shut it off. We're going to get that scramjet.
Yeah.
That was never going to happen, and what little we knew about it is just as well we didn't want to play with it anymore. And we'd run out of experiments. And the thing, if you go back and look at the X-15 program compared to other research airplanes even, or certainly operational airplanes, the airplane had everything, every single system in the airplane was brand new. There's nothing off the shelf. Every actuator, every component was a brand new part. And you had all these systems that had never even been tried before, like the reaction control system, the zero-G expulsion of the peroxide, and all of these things that had never been tried, the heating environment. And it was not very reliable airplane.
Yeah.
Terribly unreliable, as a matter of fact. We always had something come back with something broken, something that what didn't work the way it was supposed to.
Yeah.
Very complex for that time period. And as a mission planner, one of the biggest tasks we had was to figure out how to handle all these malfunctions, because we knew they were going to happen. We just didn't know which one.
Yeah.
But you had to have all of that stuff in there. The flight happened so fast that it had to be memorized by the pilot and the controller and the people that were in the control room. You didn't have time to think about it and talk about it. You had to say, if this happens, do this, and everybody had to know it.
Yeah.
And we had to spend hours on the simulator figuring out what to do if you lose number 1 APU, or if you lose the number 2 generator, or the augmentation system goes out. All of these different things that can happen. And we managed to come up with schemes that would get the airplane down safely for almost all of those.
Yeah.
We even had one for a complete power malfunction.
Is that like
that
what happened with
Pete had.
Yeah.
What we had looked at was, if you had a complete electrical power malfunction, that the game was that you would still have some residual hydraulic pressure. And what you would do was center the stick to get rid of any roll inputs, and dial in fullback trim, not fullback stick, fullback trim, which was about 15 degrees of elevator. And if you did that right, and you got them reasonably symmetrical before you lost all your hydraulics, then you could fly the reaction controls, because it was a manual system, and you could make an entry, keep the wings level. On the simulator, you could do this anyway. You could fly the thing down, it would make a normal entry, and after the thing recovered and was in level flight and below Mach 3, you punched out. Because if you couldn't get anything started.
Yeah.
And Pete really didn't do that, but he did understand it, and we had practiced this stuff enough that he knew. Have you talked to him about that flight?
Yeah.
He knew that if you get the nose up far enough where it begins to wander, that's the directional stability boundary was right about at the angle of attack you had to have for entry. So he'd just bring it up until the nose began to wander and drop off a little bit, and that's what he did.
Yeah. He's a good pilot.
Yeah, he did. But all that stuff, we'd practice what happens if the inertial system fails, what happens if all these things. And we had ways to get the airplane on the ground for almost all of them. And they all happened at one time or another.
Yeah. But one of the things on that electrical failure flight was, I guess, as you're saying, you plan, if this happens at this time, you do this. And one of the things was, if you have an emergency and you have to land at this point in the flight, you go to this emergency lake.
Yeah, right.
And I guess that was like right on the cusp of
it was right on the
and so nobody knew
boundary.
which way it was going. Yeah.
Yeah, that's right. And I think we figured he was going to go ahead. And apparently Pete looked out the window and he could see Mud Lake, which is a very obvious landmark. Yeah. And he decided to go there.
Yeah. Yeah.
But they first looked at the next lake and he wasn't there, and then they went back to Mud Lake and they found him over there.
Yeah.
That was a scary one.
Oh, I can imagine. Yeah. Yeah, he was a heck of a guy.
Yeah, and you know, the thing, after all of the work we did on the simulator to practice this kind of stuff, no augmentation, the airplane's going to do a lot of oscillating and all that. We finally get a real airplane entry like that, and we don't get any data.
Oh no!
So Jack Koff told Pete, I think Dennis put this in his book. Jack Koff told Pete, says, we're going to put a hand crank on the oscillograph in the cockpit, so that if it ever happens again, you're going to get us some data.
uh, that was,
We would love to have seen that entry,
yeah,
full data for that entry. It would have been
yeah.
really interesting.
Yeah, needed a few ever-ready batteries in there to keep
Yeah.
keep it going there. Yeah. Was it how much as the mission planners and flight planners and stuff that you spent a lot of time with the simulator? What they called the Iron Bird, I guess, was one of the names they called it and stuff like that. Now, I always understood there was one simulator, but somebody was telling me there was two. Was there one or two? Did they have one down in North America, one up at the base?
North American had the first one. NASA had put one together that was didn't have a cockpit, but they had the aerodynamics and the computers tied in, but they didn't have a very good cockpit. And then after the airplanes were delivered, they delivered the entire Rockwell cockpit and Iron Bird to Dryden.
Okay.
And Dryden hooked that up to their computers, which were already online and running.
Okay.
So then they had the complete simulation, very much like Rockwell. Now, once we got to Ship 2, which is a completely separate set of aerodynamics, we put an X-15-2 simulation on the Air Force simulator down the road. So we had a simulation of the X-15-2, and there was one at NASA that they were using for the day-to-day mission planning on the other two airplanes.
Okay.
And eventually ours was only there probably for a year and a half, so where it was used. Planned a few flights, and then Dryden got theirs up to where they could do both airplanes.
Yeah. Do you ever know what happened to the simulator? Did it just get scrapped or whatever?
I don't know.
Yeah.
That's a good, Armstrong would know.
Yeah, I think I asked him and he wasn't even sure where it went. Yeah, I didn't think.
Yeah, I don't know.
One of those things just disappeared. Yeah, somebody bought the pieces of it or what have you. And I talked with John McTeague yesterday. One of the things was a lot of the guys I've talked to have had little souvenirs, something from the aircraft. A guy I just talked to here, he was in charge of the test stand. And when he retired, they gave him the throttle from the test stand,
Yeah.
So that was cool. But McTeague had one of the biggest things I've ever seen. He said, "Yeah, I want to show you my paperweight." And he came back and he had one of the landing skids, a whole skid, which is like 80 pounds.
Yeah, right.
Yeah.
Incadel.
Yeah. Now that's a heck of a paperweight. So that was something to see.
I got a rocket nozzle out there it was from one of the lifting bodies, but they were all the same engines that were used in the Dash 11. It was a Dash 11 nozzle.
Yeah. Oh, okay. Yeah. Yeah. Dash 11. God, that thing had a 30-year lifetime or something.
Yeah.
Yeah.
Yeah. We used to tease the engine guys that every time they'd fix it, they'd mess it up. I know one of the times they'd put in they had a switch, a relay, plain old clap relay in there. They thought, we can improve that. We'll put in an electronic switch. And they put the electronic switch, and of course the rest of the system didn't understand that fast-acting switch, and nothing worked. So they had to upgrade everything.
Always surprised that the 11 went into so many programs and stuff. I'm surprised that nothing was ever found for the 99 to do again.
Well, we did a couple of studies on using the 99 for the X-24C and a couple other possible applications, and it would have worked. And we had enough spares and parts that we had 3 engines, I think, and you could support 2 airplanes with 3 engines. We figured you could support 2 airplanes flying. You wouldn't be able to support 3 airplanes flying, but you could support 2 airplanes, and there was enough that you could have done that, but it just didn't ever happen.
Yeah. So many paper studies that get canceled and stuff.
Yeah.
Dinosaur of the sea. Yeah. How far could we be along if any of those had gone forward? How much money was spent on all those studies that were just canceled? Yeah. And you got people like Bird out here showing what you could do, you know, with $20 million and some good people. Pretty amazing what happened with that one, that's for sure.
Well, Marshall has not been helpful to NASA.
Oh, yeah.
They have badly managed all of those programs. That's where the management has come from for the last 15 years, and they have really messed up.
Yeah.
Too bad.
Yeah. What was your, well, is it when you got ready for a flight itself, now you were doing all the planning ahead of time, so when it actually came time for the flight, what was your function during a flight?
Well, Dick and I usually were on the stability and control strip charts.
Okay.
And then in addition to that, we had decided early on that we didn't trust the inertial system, and the best way to control engine burn time, which was real critical to range and altitude and everything, was just time. So we initially said, okay, well, we'll put a stopwatch in the control room, and we'll time the flights, and we'll tell them when to shut down. So I was running the stopwatch for those early flights, and then we finally decided to put it in the cockpit and put a solenoid on it. And so then we were just backup at that point. But that's usually what we were doing is watching the stability and control. And Glenn Robinson was there too, looking at stability and control. And then we also did, like when Johnny came in, the mission planners were kind of responsible for the energy management on the map, telling the guy when to do what and how to get the airplane pointed back. So they were watching the map and then telling the controller what to tell the pilot to do. Okay. So those were kind of the two functions that we had.
So you spent the flights actually in the control room?
Yeah, we were in the control room. And initially, the first flights on the envelope expansion, we were concerned about the stability and control of the airplane. So that's why Dick and I were watching the stability control real close, comparing it with the simulator, and making sure that what we saw was what we expected to see.
First powered flight, of course, was Scotty, and he got into that PIO.
Yeah.
Porpoising around there.
Well, that was on the glide flight.
Yeah. So was that something were you in the control room at that time? Were you watching?
No, well, that was on the first glide flight, and I was in Seattle at that
time. That's right. I'm sorry. Yeah.
But we hadn't seen that in the simulator. But that was the reason it had two sticks in there. Was center stick was more like a normal airplane, and the side stick we always had a little concern about.
Okay.
And Scotty decided to use that side stick on the first flight. And if he'd been the center stick, I don't know whether he would have had the same problem or not. But it did cover the problem. Some lag in the system. Stuff that was correctable.
They say, you had all the simulations, you knew where it was supposed to go, but then finding out what really happened in real life and then modifying things. Did you oftentimes take data from flights and modify the simulator because of that? You were finding out the simulator?
All the time. Okay. It was a routine that we went through. We'd go out and have a guy do 3 or 4 pulses, rudder pulse, an elevator pulse, an aileron pulse at some Mach number. And we'd come down and we'd look at that time history immediately after the flight. And compare it with the simulator. And then we go down to the simulator and try to duplicate the same size inputs, the same airspeed, try to duplicate it on the sim, the same as we actually had in flight. And if that came out perfect, well, then that was fine. If it didn't come out perfect, which usually it didn't, then we went through this matching process on the simulator in real time. We'd go down there and change the directional stability a little bit and see if that made it match better. Trial and error, work through the simulator until we got something that matched what the flight data was. And then we'd leave the simulator that way. We'd make that change in the simulation and plan the next flight accordingly.
Okay. were there any times when you found that somebody was training for something specific in the simulator and it just didn't work that way in flight at all? I mean, we weren't even close.
The only thing that we found that was way off, well, not really way off, what we knew about it is, as it turned out, North American built their simulation based on their early wind tunnel tests, which were done with the model with the control surfaces at 0. Horizontal tail was at 0. And they built the simulator that way, and we did early flights that way, or not flights, early simulation that way. Planning we did with that simulation. And about the time we went to Johnsville the first time to do the centrifuge program, just about the time we left to go back there, North American got their second set of wind tunnel data where they had run all the stuff with the elevator at trim settings, at non-zero settings.
Yeah.
And it made a dramatic difference in the dihedral effect. So we got back to Johnsville, and that's one of the first things we did is we said, okay, let's put this updated dihedral effect in the math model. And we did, and you found you couldn't make entries.
Oh. Okay.
Pretty
so
severe.
How'd you get around that then?
Well, there was a lot of circular motion, go back and check and make sure that's right, and everybody's got to validate that. And we did most of the simulation, most of the centrifuge program with the old data. And we hadn't validated this new stuff yet, so we did most of the simulation with the old data. And you could make entries with augmentation off from 250,000 feet. It was scary, but you could do it. So everything's fine. But then we got back and we started looking at this new data, and it looked like it was more like 200,000 feet was as high as you could go and still make a safe entry. Because we had this dihedral effect problem. Well, as we started into the flight test program, one of the things that we did on the early Dash 11 flights is we'd get out to about Mach 3, pull up to this entry angle of attack, and do a pulse, and turn the dampers off and see what it did. Well, we did that a couple of times, and it did just like the new data said it was going to do. So we validated the new data, which said if we lose a roll damper above 200,000 feet, and it was a single channel roll damper, we can't get it back. So that forced a change. We got all the way to Mach 6, but we stopped in the altitude expansion at 200,000. And then we went through this exercise of what do we do now? We put a backup roll damper, several different options, but the one that Dick and I proposed was take the ventral off, and they did both. They got a backup roll damper in there, which allowed you to fly higher. Of course, the X-15-3 had the adaptive system, so it could go higher anyway. And then we finally took the ventral off, and the problem went away. But that whole issue kept us from getting to the 250,000 feet quicker than we held us up. I don't know, maybe a year.
Yeah.
5 months.
I'm surprised at how much difference that it made. I mean, they said from the beginning they needed that lower ventral on there, and then later on it's like we don't need it. It actually is detrimental.
But what we found was, and that's an interesting story too. The initial testing that was done in that was part of the simulator program, at the centrifuge program at Johnsville, was as you get out of the atmosphere and you run out aerodynamic control, if the thrust engine's misaligned, you get this huge side slip. And you could lose control because you didn't have enough rudder to control it. You didn't have enough reaction control. So that was the purpose of the big vertical tail. Big rudder so that you could control it right up to shutdown. Once you shut it off, then of course you could maneuver and reconfigure the thing to what you wanted. But that was the purpose of this huge vertical tail. And somewhere along the line, the rocket engine guys figured out how to align the engine better than what the original specs were. There was a fair amount of of slop in how you could mount the engine, and you could get it off by a degree or two, which was really bad news.
Yeah.
So they found a better way of aligning it with some optics or something, and they had it down to like a quarter of a degree or something like that. And if you used that, you didn't have anywhere near as much of a problem at engine shutdown of thrust misalignment.
Yeah.
So that allowed you to say, okay, we don't need the ventral anymore.
Okay. Yeah. Except the program, what was it, at least half the program flew without the ventral, if not more.
Oh, most of it, yeah.
Yeah, about 2/3, I think, or something like that. Yeah. Okay. Yeah. Well, what was out of the whole program? Is there some specific flight or anything, a moment that stands out more than any other?
Well, I think that flight of Pete's has got to be the one that us engineers marvel at, because that's the kind of thing we were planning to avoid, and and having a complete power failure and a complete dampers off seat of the pants entry was something that you didn't expect to have to do in the airplane.
Yeah.
And he pulled it off. He did a great job.
Do you think if any other pilot had been in there besides Pete that it would have been as successful?
Oh, that's hard to say. It's a matter of how much the rest of them were listening to what we were telling them. I think most of them probably would have done it.
Yeah.
Would have been able to do it. But I don't know. That's a tough question. Pete was a really good stick. He could figure out what was going on, and he was really sharp at that.
Now, you said there wasn't any official rivalry between the Air Force and NASA and stuff, but there was a little bit of unofficial rivalry as far as who was getting the record flights. It was like Bob White got 4, 5, and 6.
Well, what we had decided early on, and this is Walt Williams and the pilots and everybody, all of big high management were all there, and they said, okay, what we're going to do is we're going to expand the envelope, and if we can, we will let the Air Force set the speed records, and NASA set the altitude records.
Okay. Yeah.
And that's kind of the way it went out, although, if we got out of sequence and if we had an Air Force, NASA alternating flights, and depending on where we were in the sequence, it didn't always work out that way, but usually that's what we tried to do.
Yeah. Now, of course, in all this mix too, you obviously had the at least early in the program, you had the Navy as part of this too.
Yeah.
They didn't really participate that much in the program. Peterson only had a few flights and then left. Any commentary about the Navy part of the program?
Not really. Pete was a good flyer, and he fit in good, and we stuck him in the airplane when the time came. I don't remember where he first flew. He made a -11 flight, and he flew. I guess he flew before we had the second generation of pilots come in, and I think he flew before they came in. Engel and those guys.
Yeah. He was still pretty early.
He was in the first.
Yeah.
Cadre of pilots.
Yeah. Well, one of the stories that I got actually when I talked to Peterson was that he told me he would not give me the guy's name, and I don't know. I've still never been able to find anybody else that knows it. I did get Stan Bouchard at least to verify the story, but the story that he told me was that the Navy had planned to continue in the program, and they actually went so far as to send a pilot out to replace Peterson. And that basically, when the poor pilot got out here, they said, we don't want you, and sent him packing. Because apparently somebody had gotten the word from the Navy that the Navy pretty much wanted to use the X-15 as a rung on the promotion ladder type of thing, not as a research program. They were planning on sending a guy out, do a few flights, pull him out, bring another guy in. And NASA and the Air Force got wind of this, and it's like, no, this is a research program, so we don't want you if you're not going to be here as part of the research program. But I would give anything to find out who this poor pilot was that had to go through and get
I
stuck
never
in the
heard
middle
that.
of that.
That's a new one. I never heard that.
Okay.
I'm not surprised, but I
Yeah.
just never heard that.
Yeah, I say Pete told me the story, but he absolutely refused to tell me who the poor pilot was. And then Stan Bouchard said, yeah, he'd heard about it and stuff, and he remembers some guy coming out, but he had no idea what the guy's name was. So, yeah, somewhere out there, some poor guy that remembers the X-15 program very badly.
Yeah.
Sure. Yeah, it was a.
Well, it was a kind of an airplane that
Yeah, still a few minutes
it's a lot different than a normal airplane, and it was you spent a lot of time training the guy for that very first flight,
Yeah.
and you didn't want to be doing that all the time.
Yeah.
So it was that I can understand the idea if you're not going to be there and really participate in the research activities. If we're going to do checkout flights for that's not a very efficient way to use the airplane.
Yeah. You know, there was sort of some of that from the Air Force side of things too, and that at the time Chuck Yeager was running the test pilot school out there, that he was lobbying to try to get an X-15 for his test pilots, and they adamantly were against that, which led to the NF-104 program.
Yeah.
But it's one of those weird things where I've heard from many people about Chuck Yeager, and it's the kind of thing where I've mentioned the X-15, and people will say, "Oh yeah, Chuck Yeager flew that, right?" It's like, well, no, he didn't. But that if you actually ask the question of Chuck Yeager, you know, I haven't done this myself, but I've heard of people who have done it. Ask him if he flew the X-15, he won't deny it. You know? And I've actually got a photo of him with a model of an X-15, which is interesting because he never went anywhere near the program pretty much. So he did fly on one of the, he flew on the B-52 one of the times, but it was an abort. It was never actually launched. But that's as close as he got to the
He came
program.
down through the X-15 simulator a couple times.
Oh, he did. He did fly a simulator. Okay.
Yeah, well, yeah, just occasionally he'd wander in and fly it. And as I remember, he wanted to get Jackie Cochran a ride in the airplane too, and that didn't go over very well.
Yeah.
But it was, even for the Air Force turnover, we didn't have a lot of guys that, Rushworth was there for a long time.
Oh, yeah, yeah. Yeah, him and McKay, right in the middle of the program, the NASA guy and the Air Force guy.
They did all the flying, really.
They were the workhorse guys, yeah.
Right.
Absolutely.
That's right. But that whole affair of checking pilots out was, that wasn't a strain. It was just, you had to take a guy and he had to understand what you were doing.
Mm-hmm.
And if he was going to be a fighter pilot, and I don't need that simulation stuff, I can fly it. You know, you had a problem right off the bat. If the guy was a big ego and was not willing to accept the procedures that we were using to train the pilots.
Mm-hmm. Did you have?
We didn't have that problem.
Yeah.
I guess the one exception was McKay, and he was a stick and rudder guy early on, and he would use any excuse to get out of flying the simulator.
Oh, yeah.
And he'd fly the simulator, and he'd say, "Well, airplanes doesn't fly like that. Doesn't, you know, you've got this big dip out there, and it doesn't do that." Then he'd go make his next flight. He'd do this big dip, and he'd say, "Oh, well, yeah, I guess that's really there." And after he did a few flights in the airplane and a few simulation runs, he began to realize where the advantages were, what was real and what was not real.
Yeah.
And he became a user of the simulation and the training, but he was probably the most resistant to it of any of the other guys.
Yeah. There was never any guys that were brought into the program that basically washed out because they couldn't handle the training or anything like that. Yeah. Yeah. Well, I know people like Milt and stuff talked about it. Of course, they came in later in the program. You had the guys at the early part of the program, especially if they got to build up through the LR-11 thing, where, you know, they were doing Mach 2, Mach 3 and stuff. And it's like Milt's first flight was out to Mach 5.
Yeah.
And I know he talked about how nobody really prepared him for that. Nobody prepared, if anything, the worst part was that drop off the B-52. Nobody told him what it was like being shot off the B-52.
Yeah. Minus G's there, that's right, yeah.
I think Bill Data talked about the same kind of thing. And I guess it sounded like it was one of those things where the guys from the earlier program, it's like they knew exactly what these guys were going into, and they didn't want to tell them on purpose. Yeah, they were having a little fun here, you know. Yeah.
Oh yeah, there was some of that, and Walker, one of the first flights, he made the comment that this thing, it began to, when it cooled off, it would pop like a stove.
Yeah.
And he could hear that. He could hear the panels popping, bang, ping, pong, you know. And he mentioned it in a post-flight, but nobody else ever mentioned it after that. And that was another thing that the guys would comment on their first flights.
Oh, I can imagine. Am I losing panels
What's
back
that
there?
noise?
Yeah. What's falling off of my aircraft? Oh man. Oh, let's see. This should be just about ready to change here. Yeah, let me go ahead and switch this off here. He actually had a test that he was part of that was like a new way to gauge whether or not a pilot was susceptible to vertigo at high altitude. But that since it wasn't a standardized test, it was experimentation, that the results would not be held against you. And I remember hearing that they said that he came out very susceptible to vertigo in these tests, but again, it was not on his record, so yeah.
That's right. Yeah, it's a motion chair thing.
Yeah.
And most pilots would get badly disoriented and recover in a matter of seconds, a minute. And he was messed up for 10 minutes, something like that.
Yeah.
Very, very susceptible to that problem.
Yeah. Well, now you were out there when the accident occurred. You were at the control room that day.
I know I wasn't in the control room, but I was around. Johnny kind of took over the mission planning stuff.
Okay.
When he got there, which was say 63, 62, 63, and I was doing X-20 at that time, so I was off doing the centrifuge program for the X-20 and other stuff. And then when the X-20 was canceled, then I went back and we're doing both X-15 and some of the other lifting bodies.
So you were doing all those programs simultaneously. You weren't just stuck on X-15 and that was it.
That's right. I was kind of working. We had a joint program on the lifting bodies as well, so that I had engineers working. By that time, I'd moved up to a supervisor, and I had a couple of engineers that were working on the lifting bodies and ones that were working on the X-15.
Yeah. Was there quite a bit of crossover between the programs at that time, between the lifting bodies and the X-15?
Yeah, there was.
Yeah. Sure, this is still... Oh yeah, that's fine. Okay. Yeah, actually, I'd like to talk to you a little bit about the X-20 program. That was really had the potential to be a very exciting program. When did you first become involved in that?
Early on, would have been source selection was in '59, I think, or maybe there were several source selections in there, and I was involved in one of them. And when Boeing was selected to do the glider, and shortly after that, the higher-ups were deciding how the pie was going to be divided between the Air Force and NASA and the contractor and all that. And we decided that the Flight Test Center would be lead on the flight planning and the flight test operations, and NASA would support us. So we had the simulation. We put on a simulation of the X-20, and I participated in the Boeing simulation of the boost phase. And then we went back to the centrifuge and did some boost runs back there. I actually got to ride the wheel once. I got to ride on it.
Yeah.
Flying an
X-20
boost. Titan 3 and the whole thing,
You did a full X-20 profile?
Yeah.
Yeah.
I was kind of the responsible engineer for the model at the time we went back there, and we just took the Boeing model and stuck it on the old ancient equipment that Navy had back there, and so I was kind of there for a couple, 3 weeks checking it out, make sure it worked, and then when I got all through with we got the pilots in there and flew the program, and then after all of the astronauts had flown the program, well then I asked if I could have a ride, and they said, yeah, you can go ahead. Right in there, and I got my suit on, and Harry Bratt was the flight surgeon, Lieutenant Colonel Air Force Flight Test Center flight surgeon. And I said, hey, Harry, aren't you going to put all these monitors on me and see what my heart is doing? And he says, looked at me and he says, I see you're a flight test engineer, aren't you? And I said, yeah. He says, well, you're expendable. But that was an interesting program from a lot of standpoints. The time we started out on the X-20, it was an extension of the X-15 program. It was going to go Mach 17 or something like that. We were going to launch it out of the Cape and land at Grand Bahama and then Fortaleza and gradually build up. And if everything went well, we might go orbital once around. And of course, by the time the program ended, that was the first flight. And the risk was going way up. The payoff was going down because the military wanted to make this into a military system right off the bat. And it wasn't designed that way, and it really wasn't in the cards.
It was a test program.
It was an X program, and it was started out that way. And there were some things that happened. One of the things that I observed, I wasn't involved in it, but Boeing went through the process of an escape capsule. Got to have a capsule on this thing, because that was the pet thing at Wright Field.
Okay.
And they went through the process, and they had to figure out how to keep it stable and make an entry, and had to have a reaction control system, and it had to have dual this, and it had to have power. And somewhere, somebody was smart enough to recognize, wait a minute, we're building two airplanes here. One inside of another one, and we'd be far better off to build one that's redundant and robust and save a lot of weight. And so they won that argument. And that was the first time, I think, that had come up. And if you track that through, the X-15 was that way. It didn't have an escape system. The seat was, 80,000 feet, Mach 3. The airplane was quite a bit farther out than that. Well, we got the same thing on the shuttle. And that kind of became the way we do things, is you put the redundancy in the basic machine, and you don't try to have an escape method.
Well, I heard
you can't afford it.
I heard at one point they were talking about the same thing, putting a capsule system into the X-15. And I think
they did.
I don't know if it was Scotty specifically. I know he talked about it in his book, was the fact that the X-15 itself is your escape capsule. If you're up at high altitude, you stay with the airplane
just
until
hang
you get
on
down low enough, and it will protect you till it gets
it was
there.
built like a bridge. The margins on the structure were way up high because they built the airplane. They decided how much metal they needed in order to handle the air loads, and then they said, how much now do we need to heat sink the temperatures, and they just added leading edge and spar until they had enough structure to heat sink. So it was way over designed, and that was a perfectly legitimate approach to that program, I think.
Well, even on the Mike Adams crash, I remember, I think when it finally broke apart, the G levels were much higher than the design.
It was 13, 14 Gs.
It was only made like plus or minus 7, I think, was the design on it, something like that. So it's almost doubled before that finally broke apart. That was a heck of an aircraft. So do you think that with the X-20, that because of the way it was going and what was happening to the program, that it was the right thing to do to cancel it?
Oh, I don't know. I guess at the time it was canceled, our biggest concern was that at the time it was canceled, there was going to be one unmanned flight once around, and then you're going to put a man in it and fly it once around, and then you were going to go up and stay in orbit for, it was way more. It wasn't doing what the research was that we wanted to do. And all of us felt like at that time there was no tracking system, worldwide tracking. So you're going to launch this thing, and as soon as it got out of range of Kennedy, you're going to have this unmanned blivet going up there, and it had a very, very narrow window to enter to make it to Edwards. It was really small. So
not a lot of
we figured, well, it had plenty of cross range, but to make the once around, you had to start your entry here pretty close. And if you overshot, you could be, it was less than a quarter of a degree, something like that,
wow.
that you had to be flight path angle at the time the Q built up. So you had plenty of cross range to make corrections, but there was a limit to how much you could do. So we figured the thing was going to go up there and you'd never see it again.
Yeah.
If everything went well, you get the boost off, and then you'd never see it again. And if you did see it again, it was going to come in and land at Edwards. That meant right over the middle of L.A.
Yeah.
This unmanned blivet, and they were going to try to mate up with a drone concept and take over control from another airplane and fly it down. Well, there weren't any airplanes around that had that low on L over D, and it was coming down at a pretty steep angle.
Yeah.
And somehow they were going to land it, and we didn't ever think they were going to get it on the ground. So if you had anything like that happen, if it wasn't a complete 100% success, the program was going to be through anyway.
Right.
That was our concern.
Yeah.
And you say, well, why don't we put a pilot into the first time? Well, there were a lot of firsts, but by that time the program had gotten so pushed out so far.
Yeah.
But looking back on it, if you look at the shuttle results, it probably would have worked. The aerothermodynamics that were predicted at that time were probably okay. The metallic heat shield had been tested on the asset, and it was okay. The pilot workload was way up there, would have been way high, controlling the airplane and the whole problems. But I think that the concept was reasonably sound. If they'd have gone back and done the build up,
right,
like we did on the X-15, starting at the Mach number and building up and testing the parts and the components to make sure they were all doing what they're supposed to, I think it would have worked.
I had a concept painting with the X-20 where it was being carried aloft by a B-52 and had like a booster rocket stuck on the back of it.
It was the escape rockets.
Yeah. Okay. I mean, the thing, it looked so big, there was no way the B-52 could have carried it or whatever. There's no, the undercarriage wouldn't have cleared it and stuff. It was just a really bizarre concept. I mean, the rocket on the back was, it was like the third stage of a Titan or something stuck on the back of this thing. And like I could have seen the B-52 trying to carry that thing aloft.
But we looked at one where the X-20 was nestled in two big tanks that were in a V. The airplane was sitting in the middle, and there were rockets on the back of the tanks. And we went up to the limit of the B-52 weight, which was like 57,000, something like that. And with that, you could get the thing up to about Mach 15. And that wasn't a bad concept, but that, that at that time, the whole environment at that time was we got to get to orbit.
Yeah. I know there's, the X-20 was one of the programs. It's like, I think people, for lack of a better term, cry over more than anything else that it never happened. Yeah.
Well, a lot of people don't know how far along it was. They don't recognize that it was in the jigs. There were real parts up there.
My understanding was the first airframe was up to like 50% built. Was that far along?
That's right.
Okay.
And the problems that they were having, we were having all kinds of problems politically in the testing and the organization. But if you go up at Boeing and talk to the people up at Boeing, the problems they were having were trying to work with these exotic materials. How do you drill a hole, put a rivet? How do you put this thing together? And those problems were going to slow it down. There's no question it would have been delayed while the manufacturing problems were solved. But they were solvable.
Yeah.
It's like the tiles dropping off down here at Palmdale in the shuttle.
Oh yeah. It's that was amazing if they would have been able to pull that off. Do you know what happened to the flight vehicle? Was it just scrapped?
No, I don't know what happened to it. I don't think I ever saw it. I saw pictures of the thing in the jig, and there were tail things up, and I imagine it was just scrapped.
Yeah, yeah. Same with the full-scale mock-up that was used many times. It just disappeared.
Yeah.
Yeah. I remember I've been, asking around about it for a long time, see if anybody, it could have been somebody's backyard for all we knew. I remember one guy that ran a museum back in New York, the Cradle of Aviation Museum back there, and he said, "Oh yeah, we got that." It's like, "You do?" And he sent me a picture of it, and it was like it was a lifting body, like X-23 lifting body or something like that.
Yeah, okay.
So this is not the dinosaur.
Looked a little like the HL-10.
Yeah,
I've
exactly.
seen that one, right.
Yeah.
That's fairly recent.
Yeah, and so he was trying to tell me that was the dinosaur. I was like, no, it's not. Yeah, it's not even the right color. It was white instead of black.
Yeah, right.
So, yeah, yeah. I see the closest I think I've seen that still exists on that is a wind tunnel model that's still in the Smithsonian. Beautiful wind tunnel. It's about this big. The steel or whatever. It's just it's gorgeous. Yeah.
Do you know where the X-15 wind tunnel model is?
Well, I know they've got a couple of them up at at Edwards at the museum up there.
Well, is it the museum? It used to be at the Officers Club.
Oh yeah. Oh,
It was hanging up over the entrance to the Pancho Barnes room at the Officers Club. I don't know if it's still there or not.
Okay, well there may be another one too, because I know they did, or it could have been.
Yeah,
moved
there
over
were
to
several.
Yeah, there's at least two. They actually have the Delta Wing wind tunnel model also, and that's all up there at the museum. So it's nice that they've been able to collect some of those things. I've actually got a large X-15 model myself that I'm still working on restoring. It was an original model that's about 4 feet long of the X-15. It's like 1/12 scale, something like that. And it was donated to a museum, and the museum broke it, and it was eventually, I was able to get a hold of it and put it back together. It was literally cracked in half, and the tail was missing and stuff like that, so I've been slowly putting it together.
Was it a wood one? A low-speed one?
It's wood, and this is all, it was display, it wasn't for wind tunnel.
Oh, okay.
Yeah.
Okay.
So, but yeah, the thing is just gigantic, it's just beautiful, and I hated having to, as I say, it was all broken, so it had all the markings and stuff on it, but I pretty much had to strip it all down. I sort of hated having to do that, but we had to sort of get it down to the basics to start building it back up again. And it's all back together now. The pieces are in place, and the only thing that I really couldn't do myself is to do the decal work on it. And I've got a friend working on that, and I'm sort of waiting on him to finish the decal sheet for this giant X-15. In fact, I just got some of the decals from him over Christmas, so hopefully it will be fully restored before too many more years pass. And,
yeah, I got one. We flew an X-15 model this morning, as a matter of fact.
Oh yeah.
I think we'll show you that.
Oh sure. Yeah. How do you feel about the SpaceshipOne program, especially relating to the X-15? It's now flying not the speed, but certainly the altitude of the X-15.
Yeah. Well, it was. I think I'm the only one that worked on both programs, the X-15 program and the SpaceshipOne program. And Bert asked me to come up and kind of consult, which I did, and I did some aerodynamic analysis of the test data too. So I was not just watching, but that program was really high risk, if you think about it.
Yeah.
But it was high risk kind of the same way the X-15 was, is that the risks are very high, but these guys had thought about all the options, and they pretty much had a way of getting the pilot back regardless of all of these things that could go wrong. So they had really thought it out pretty well, and they were going about it like we used to do back these days when it was okay to take a calculated risk. Can't do that anymore.
Yeah.
But we look at the thing and say, yeah, we think we can do this, and if it doesn't work, we'll get the guy back. Hopefully you get the airplane back too.
Yeah.
And they took that approach. But the airplane is a real squirrel. It doesn't have any dampers, and it's just PIO prone. Everything is happening very, very fast, just like the X-15. If you fly the X-15 without any augmentation.
That second flight when he was doing what, 29 spins or whatever it was. As he's
Oh,
going
yeah,
up.
and doing rolls, yeah.
The
Well,
rolls, yeah.
they had a lot of problems,
Yeah.
but in each case, the feather thing is like a parachute. It does allow you to get out, unless you're at really high Q. It allows you to put the feather up, and the airplane will stabilize and come down like a parachute. And if you're high enough, you can recover, or you just kick the nose off and step out.
Yeah. So it did have that kind. It was the nose jettison.
Yeah.
Yeah.
So they thought about all these things, and they had ways of getting the pilot back. And if you lose the airplane, you lose the airplane.
Yeah.
But yeah, they had their problems. Mike's got into a spin,
Oh,
the first one, and then
yeah.
Brian landed, one
Yeah.
gear collapsed,
Yeah.
and they had made some changes to the control system that they probably shouldn't have made. And so they had their share of difficulties, but it was pretty well planned, I thought. In terms of the way the planning was done, it was very much like we were doing the early envelope expansion here. You expected a lot of problems, expected you didn't have all the answers, and that you were going to have some difficulties, and you planned around those. So that if this happened, here's what you do.
You were out there the day that they did the third flight, the second X-Prize flight when they actually broke the X-15 altitude, right?
Yeah.
You were in the control room that day, right?
Yeah.
Yeah. So what was your thoughts at that time? Anything special run through your mind when
Well,
you knew they'd broken the record?
I think my feeling was kind of like if you talked to Pete Knight before he left, and asked him about his speed record, and his response would be the same as mine about the X-15 altitude record, is it's about time.
Yeah.
That was 40 years ago,
I know.
and here we are,
Yeah. We've
just
been doing
now
nothing.
breaking it. Yeah.
Yeah. No,
Certainly, none of us that were working on the X-15 at that time felt that those records were going to last as long as they have,
Yeah.
speed or altitude.
Yeah, speed record's still out there to be beaten someday. Yeah.
Yeah.
Unless you count the space shuttle, of course, but that's not really the same thing. Yeah.
Well, maybe not, but it's the space shuttle would have been in the same category as the dinosaur if it didn't pull it. Had a booster behind it.
Yeah. Are you sorry that the X-15 program didn't continue through something like the Delta Wing program that they were talking about?
The Delta Wing program would have been a good program, yes. I think that would have been beneficial all around. We would have learned a lot from it.
I know they were talking, the main reason I've always heard they canceled the Delta Wing was because they lost aircraft 3, which is the one they were going to modify.
Yeah.
Why couldn't they have gone back and modified one of the other 2 aircraft? Especially, I think, aircraft 1, which didn't have the lengthening and stuff like aircraft 2 did already.
Well, yeah, I think one of the reasons they wanted to use number 3 was because of the control system.
The SAS, yeah.
And they would have had to install I'm not sure there was one around. MH-96 control system was kind of unique to that airplane.
Okay, yeah. I guess a lot of the hurt went out of the program after the crash, too.
That's right.
Yeah.
Well, they were running out of things to do with the airplane. As you say, it was all research by that point. We knew everything we were going to know about the configuration. And the Delta Wing would have been a good program. I would have liked to have seen that, even if it didn't go as fast. Just the idea of taking a hypersonic configuration. This airplane is like a 104. It's a Mach 2 airplane that they pushed out to Mach 6.
Yeah.
That's all it really is. And the Delta Wing would have been a hypersonic configuration that was designed to fly at high speed. Then I think we would have learned some things about heating, about stability.
Yeah, that would have been interesting. Have you ever gone out back to the Smithsonian or Wright Pat and stuff to look at the old airplane?
Oh yeah.
Yeah.
Johnny and I have often compared notes. We go back to Wright Field. And we walk outside where all the airplanes are sitting outside there, and we recognize tail numbers.
Okay.
That makes you feel old.
One of my hopes is on this big cross-country trip I get left to do is that one of the stops I'm going to do is back at Wright Pat. I've been there before, but I want to spend more time there and go through their records and stuff. They've got some pretty good records on the X-15 back there. But also I'd love to be able to talk them into opening up the cockpit on that aircraft and see what's inside. I know some of the guys have told me about some of the things. There's some placards inside. You know, the thing about the landing gear when it was coming out at Mach 4.
Yeah.
And somebody said they put a placard in there. It's got on the instrument panel, "Do not deploy landing gear above Mach 4." You know, he's like, I want to see if that stuff is still in there. So I hope I can arrange to do that stuff when I go back.
Armstrong used to have a whole bunch of the master caution lights.
Oh yeah.
The covers for the lights.
Oh, okay.
I don't know whether he or McTeague, or both of them, they used to collect those, and they would appear at parties and things. You know, peroxide hot light.
Oh boy. Well, I know Johnny still has I presume he still has the spike from the ramjet.
Yeah, he still got that.
Yeah. When I talked to him, he was out there and he pulled that out of his desk. I just couldn't believe that. Yeah. Oh yeah, that's a heck of a thing to have. Yeah. Was there anything special about the program that you want to say that we haven't talked about yet? Overall feelings about the program?
Well, other people have said this, and I think it's very true, is that the whole concept of the X-15 occurred at a time period where the national interest could support it, the research people could support it and build it, and the environment was such that you could go fly it, take the risks. You can't do that now. We would dump, I don't know how many 1,000 gallons of ammonia into the atmosphere coming back. And all of the things that we were doing, you couldn't do today because of the liability and everything like that. And at that time period, you could. And you had, Congress was in a mood to support that kind of thing, and so were the people. It's extremely expensive. The program was, I don't know what, 8 or 10 times what it was originally estimated.
Yeah. I think the overall program was $200 million from start to finish, and $1960, of course. I don't know what that would equate to today, but quite a bit, about maybe 5 times that or something.
Of course, it went longer than we asked the North American guys. What was his name? Bill Johnston. How many flights he thought, when you were designing this airplane, putting together the heating and all that stuff, how many times did you think it would fly to Mach 6 or to its design condition, each airplane? And he said 5 or 6.
Definitely beat that one out.
Yeah.
Yeah.
So they weren't designing for a long, long time. The same thing's happening with the shuttle.
Yeah.
You ask those shuttle guys, how long did they think that the shuttles would be flying? And they didn't expect them to be lasting 30 years either.
Yeah. I can't believe we just had the 20th anniversary of the Challenger accident. Yeah. It was an interesting thing that I ran across was, of course, there was a lot of hype around the X-15. The publicity on it and stuff. When it first rolled out, Nixon was there. This is the vehicle that's going to take the first people into orbit, whatever. And it's I mean, the original design specifications were basically 50 miles in Mach 6.
Yep.
And of course it exceeded that, exceeded both those things. But I've got stuff actually from North America. I've got North American press releases that talk about the X-15 is designed to fly to 100 miles of altitude and to like Mach 10. And I know, that it wouldn't have survived, a re-entry from 100 miles up. And yet they were still publicized. They were trying to tell the public, oh, this is going to fly 100 miles high. Yeah. And I always wondered if you ever heard any of that stuff yourself, being inside the program.
There was the X-15B program, which was the one they were going to sell to the test pilot school.
Yeah.
No. Yeah, the B was the 2-seater.
Okay, yeah.
And then there was the orbital one that they actually proposed to sit on top of a Titan or something.
Yeah, I've got pictures of that one.
Yeah, and it was going to go around once. And that, I don't think they ever really did a full design on that, because I don't think that configuration will do an orbital entry. I don't think you
Yeah.
could
That was
design the
understandable.
thermal protection system to do that.
Exactly.
They were talking about ablators and things. Well, we
Right.
saw how the ablators were.
Yeah. Yeah.
So I don't know how serious they were about it.
Yeah.
So those programs I was glad to see not happen.
Yeah.
You know, the two-place one at the school would have been even worse than the NF-104. And but the Delta Wing, that would have been a good program. I would like to have seen that happen.
Yeah. You gonna build one of these in a Delta Wing sometime?
I don't think so.
Well, you've done, that's really a very, very excellent job you've done on that. I definitely commend you for
That's
your-
getting a lot of scars now.
Oh, yeah.
All the grass and stuff,
Yeah.
but it's I don't know how many times I'm going to fly it, how many more times. It seems to be
Yeah.
holding up, you know, the thing
Yeah.
hits the ground hard, it buries itself in about that far and doesn't hurt it.
Yeah. Yeah. Pretty cool. Cool.
But the thing that's surprising, look at the amount of differential tail there.
Yeah.
That's
Yeah.
normal level trim,
Mm-hmm.
and I don't know why.
Yeah. Hmm.
That's about 10 degrees of left aileron,
Yeah.
and yet the airplane, if you look at the airplane, you don't see anything that's out of alignment by that much.
Yeah. Yeah.
So I haven't figured out why it's that difficult to.
Hmm.
That's what it takes to fly level.
Huh. It was like on the real aircraft when they were first dropping it and finding it always had that roll to the right.
Yeah, that
Yeah.
was the B-52
Mm-hmm.
flow field. All of the airplanes that we've dropped